Welcome back to Lesson 83 in Saxon's third edition of Algebra 1. This lesson is on coin problems. This is one I told you that this was going to be coming up soon when we did the lesson entitled Subscripted Variables. I told you they were going to use those for coin problems. So let's get right down to it. So here's our problem. Jack and Betty have 28 coins, and that consists of nickels and dimes. If the value of the coins is $1.95, how many coins of each type do they have? So this is going to be a system of equations. We're going to I'm going to use substitution here. You could use elimination if you would rather. But the first thing I have to say is number of nickels plus number of dimes is 28. And then the value of those is 195. So in value, the value equation, we have to attach value to each of the variables. So 5 times the number of nickels plus 10 times the number of dimes equals 195. This is going to be the equation that I'm working from, and this is going to be the one that I'm going to substitute. So I'm going to substitute in for ND, right here, 28 minus NN. So I have 5NN plus 10 times what I substituted, 28 minus NN, equals 195. Now I'm going to do the math. 5NN plus distribute 280 minus 10NN equals 195. Combine my like terms and I get negative 5NN plus 280 equals 195. Now I'm going to move this 280 to the other side to get rid of it here, and I'm left with negative 5NN equals negative 85. When I divide on both sides by negative 5, I find out that the number of nickels is 17. Now it's really easy to find the number of dimes now that I know the number of nickels because, look back up here, the number of nickels plus the number of dimes equals 28. So I've come down here, and we're going to work this out. If I now know that the number of nickels is 17, I'm going to substitute that in. 17 plus the number of dimes is 28. Subtract 17 from both sides, and I find that the number of dimes is 11, which is fabulous. All right, in this second example, Ming has $4.45 in quarters and dimes. She has 8 more. Let's change that right now because that's really bugging me. In quarters and dimes. She has 8 more quarters than dimes. How many of each type does she have? All right, we know that the number of quarters is not equal to the number of dimes. It's not equal. So what would we have to do to make it equal? Well, it says that there are more quarters than dimes. So I would have to add 8 to the number of dimes to make it equal to the number of quarters. That gives me my equation that I can substitute in. I also have a value of $4.45. So I'm going to attach value to the different coins. 25 times the number of quarters plus 10 times the number of dimes equals $4.45. Now I can come in and substitute in ND plus 8 for NQ, and then I'm going to simply do the math. 25 ND plus 25 times 8 is 200, plus 10 ND equals 445. Combine my like terms and I get 25 plus 10 is 35 ND plus 200 is 445. Subtract 200 from both sides, and I end up with 35 ND is equal to 245. When I divide both sides by 35, I find out that the number of dimes is 7. All right, so if I now know that the number of dimes is 7, I can replace that in my equation and find out that the number of quarters equals that 7 plus 8, so it's 15. So 15 quarters, and 7 dimes would give me a total of $4.45. These are real easy to check too. Just get some quarters out, play money, whatever, real money if you have it, and then check and make sure it adds up. All right. Orlando had a hoard of 22 nickels and dimes whose value was $1.35. How many coins of each type did he have? All right, so I know that the number of nickels and the number of dimes is 22. He has a total of 22 coins. They have a value of $1.35, and I'm not going to use decimals. I'm just going to put 135 cents. So I'm attaching value to the nickels and dimes. 5 times the number of nickels plus 10 times the number of dimes equals 135. Here I'm going to say, I'm going to move this ND to the other side, and I get NN equals 22 minus ND, and this is what I'm going to substitute in right here for NN. When I do my distributive property, I see 5 times 22 is 110. 5 times negative ND is negative 5 ND, plus positive 10 ND equals 135. 110, combining my like terms, plus 5 ND equals 135. Subtract 110 from both sides, and I find that 5 ND is equal to 25. So I know that the number of dimes is 5. Once I know the number of dimes, I can plug that back in right here, substitute it in, and I find number of nickels plus 5 equals 22. Subtract 5 from both sides, and I find out that there are 17 nickels. All right, let's do your practice problems. Ahmad and Regina have 36 coins that are nickels and dimes. So right now I know that they have number of nickels plus number of dimes equals 36. All right, now I've got to have a value equation too. The value of the coins is $2.90. So I'm going to attach value here, 5 times the number of nickels plus 10 times the number of dimes is $2.90. All right, so let's go ahead and subtract ND from both sides. And I get NN equals 36 minus ND. Now I can substitute this in right here. 5 times 36 minus ND plus 10 ND equals 290. When I do my multiplication, I'm going to find that 5 times 36 is 180 minus 5 ND plus 10 ND equals 290. Combine my like terms, 180 plus 5 ND equals 290. Subtract 180 on both sides, and I have 5 ND equals 110. And I know that divided by 5, 110 is 22. So now I know that there are 22 dimes. All right, so if there are number of nickels plus number of dimes, which we now know is 22, total equals 36. I can subtract 22 from both sides, and I find out that the number of nickels is equal to 14. So 14 nickels and 22 dimes. All right, Emil has 645 in quarters and dimes. He has 9 more quarters than dimes. How many of each type does he have? Okay, what we know is that the number of quarters and the number of dimes is not equal. It is not equal. What would I have to do to make it equal? Well, he's got 9 more quarters than dimes, so I would have to add 9 to the number of dimes to make that equal. All right, now let's get our value equation. Our value is 645. And we have quarters and dimes, so 25 NQ plus 10 ND equals 645. Now I'm going to substitute this in for NQ, so 25 times ND plus 9 plus 10 ND equals 645. Do my distributive property, 25 ND plus 225 plus 10 ND equals 645. Combine my like terms and I get 35 ND plus 225 is 645. Now I'm going to subtract 225 from both sides. And I'm going to find out that 35 ND is equal to, let's see, 420. And when I do my division by 35, I'm going to see that, let's see, 420, 35, that will go one time, 35, 70, that will go 12 times. So let me just erase that there so that I have room to finish what I'm doing to find my other variable. Okay, so I know that ND is 12. Number of quarters equals ND, which we now know is 12, plus 9. 12 plus 9 is 21. So the number of quarters is 21. 21 quarters, 12 dimes, for a total of $6.45. Good job. Easier lesson than we've had the last couple of lessons. So good job, good luck, and I'll see you next time for lesson 84.